Here we go. Not Tuesday. Class opener, 3, 4 is the correct answer for A. 3 on the X, 4 on the Y. B is -1 on the X, 3 on the Y. C is 0 on the X, -2 on the Y. D is 4 on the X, 0 on the Y. If you're struggling with that, please get some help or else you won't be able to move on to the next section. Right now, I want you guys to, you might not have the same artistic abilities as me, but go ahead and draw some type of machine that has an opening to put in some values, a window so we could see what's going on inside, and another opening so we could get out some values, okay? So it doesn't have to be this exact machine, but draw some type of machine. This is what I call the function machine, okay? So I need you guys to draw it right there in the available space on the page of notes that I gave you. Draw it. I'll give you guys a minute or so. So again, it doesn't have to be fancy. You don't need numbers like I put or an on and off switch. If you do, make sure it's on. No, I'm just kidding. So you don't need an awesome machine. Just as long as you have an opening for numbers that come in, a window to see what's happening, and an opening for the answers that come out. So let's do this. Give me a number. 3. If I take the number 3 and I plug in the number 3 right in here, something happens to that 3 and it comes out as a 5. Okay? Well, let's not ask why yet, but let me give another number. Anybody? 6. We'll do 21 next if you want. If I take the number 6, that's now in black, I want to plug it in and something happens to that 6 and it comes out as 11. All crazy? No, it's not that crazy actually. Give me another number. 21? You guys want 21? 21. All right, 21. If I take the number 21, that green 21, and plug it in here, something's going to happen to it, and I am going to get 41 as an answer. Does anybody see it yet? Does anybody see what's happening inside this window right here? Well, it's definitely increasing. I guess we don't see it. Let's keep going. How about, give me another number. 7. If I take the number 7 in blue and plug it in here, when it comes out, it's going to be the number 13. Oh, you know what it is? What is it?
It's basically that number twice minus 1.
That number twice minus 1. Right? That number twice, you double it and then you subtract 1, right? Look, if I take 3 and double it, that's 6. 6 take away 1 is 5. Take 6, double it, that's 12. 12 take away 1 is 11. 21, double it, it's 42. 42 take away 1 is 41. So you got it. You double it, and then you subtract 1. Now, how are we going to write that as an equation? We're going to write it as an equation y equals double the x minus 1. That's what's going on inside of the window. That's what's going on inside of this machine. Okay? And to be more specific, I take this 3 and I plug it in. Where do I plug it in? Y. Into the y? Into the x, huh? Right? Yeah, into the function machine. You see, we already know what function form is. Function form is an equation that has y by itself, right? So any function form equations like a machine, you take your input, your 3, you put it in, and where do we put it in? We put it into the x's, and you go 2 times 3 is 6, 6 minus 1. That now equals y, so y is 5. Make sense? So my 6, I put it into the x. 2 times 6 is 12, take away 1 is 11. Y equals 11. So it's crystal clear that your inputs are obviously the numbers that you're putting in. And where are you putting them into? Into the x values. So inputs and x values are the same exact thing. And same with domain. Domain is the same thing as input and x values. So these 3 words all mean the same thing. They are the numbers that you're plugging into your machine, into your function form equation. Now, the outputs, those are the answers that come out, right? When I plug in a 3, I get out of 5. That's my output. Not only that, we said that the 5 is really equal to y, so this 5 is also a y value. It's not only an output, but it's also a y value. in addition to outputs being the numbers that come out and y values being the numbers that come out, the range are also the numbers that come out. So all these three mean the same thing. All these three mean the same thing. Does that make sense? So if I told you, what inputs did we use right here? You would say what? 3, 6, 21, and 7, right? What corresponding outputs did you get? 5, 11, 41, 13. If I said, what's the domain that you used? Well, you would say, same thing, 7, 3, 6, 21. What's the range that you got? Oh, 13, 5, 11, 41. So all these words mean the same thing. All these mean the numbers that go in. All of these mean the numbers that come out. Are you with me? Okay, so a function, check it out, guys. A function is like a machine. You plug in something, you get out something. Okay? Now, here's the most important fact of the day with regards to functions. For each input, there's exactly one output. In other words, if you plug in a number and you get out an answer, then you plug in that same number again and you get out a different answer, then it's no longer a function machine. The machine's messed up, it's broken. If you put one thing in, you have to get out only one thing. If you ever end up with two outputs for one single input, then you cannot consider it a function, it's just a relation. Now this paragraph itself could be kind of confusing. But let's go back to this drawing and let's really make sense of what the paragraph says. Let's forget about numbers right now. If I take a piece of dough, yeah, I put a piece of dough into this machine and I get out a donut. That's cool, right? If I take another piece of dough and I put it in there, what am I supposed to get out? A donut. So I get a piece of dough, put it in here, I get out a donut. I get a piece of dough, put it in here, I get out a donut. I get a piece of dough, I put it in here, I get out a tortilla. That means that this machine's broken. All right? So a function's like a machine. For each input, you have to get one output. Okay? If you ever plug in the same input 2 times and get out different outputs, then you know this thing's messed up. So let's go back to numbers. I plugged in a 3, right? What did I get out when I plugged in a 3? 5. A 5. What would happen if I were to plug in a 3 again? What should I get out again? A 5 again, right? Because the machine works, right? Now, if I plug in a 3 and get out a 5 and plug in a 3 and get out a, let's say, a 15, then you know that machine's messed up. So that's no longer a function, it's just a relation, okay? So a function's like a machine. You plug in something, you get out something. If you ever plug in that same value and get out different outputs, then you know the machine's messed up, and we call it just a relation. All right? That means there's some type of relationship going on right there, but we don't know, we can't say as a function form equation. All right, so let's take a look at these input-output tables. So the question is this a function or is it just a relation? Now, let's think about inputs and outputs. So the question boils down to, do I ever plug in the same input 2 times and get out different outputs? No. So does this machine work? Yeah. I mean, as far as we know, yeah, it's a perfectly functional function machine, right? You plug in a 1, you got out a 3. Plug in a 2, got out a 4. Plug in a 3, got out a 5. Plug in an 8, got out a 10. Now, it'd be a different story if I plugged in a 3 again and I got out a 13. Then this would be messed up. It wouldn't be a function. It would be a relation. Because if you plug in 3 and you get out a 5, if you plug in 3 again, you're supposed to get out a 5 again, not a 13. Okay, but anyways, that didn't happen here. I just put that as an example of what we're looking for. So is this a function? Is this a function machine or is it broken? It's a function, so everybody should label this as a function, not a relation. Okay? So you're going to have these exact questions. They're going to give it to you as an input-output table, as a domain range table, as an XY table, and you need to analyze your inputs and outputs and say if it's a function machine that's working or if it's a machine that's broken, which means that you can't call it a function, it's just a relation. So let's look at this next one over here. Is this a function? It's broken. So what do we call it? It's a relation, right? So if it's working, it's a function machine. If it's broken, then it's a relation. So what makes this broken? The -3. The input -3 gave me a +15. If I input the -3 again, it better give me a 15 again, and it doesn't. It gives me something totally different. So that's where I say, no, this is just a relation. Now, what does that mean? It means that there's some type of relationship here between the domain and the range, between the inputs and outputs, but we can't narrow it down to a function form equation like y equals x plus 2. You just can't do it, right? So that's what we call a relation. There's some type of relationship, but it's not a nice functional machine where you plug in a number and you get out an answer. Is this a function or just a relation? A lot of people think it's a broken machine, but it actually works. This is a function. Now, is it possible to plug in different numbers and get out one single answer? Yes, it is. Check it out. Y equals 0x plus 3. If you take the 4 and plug it in right here into the x, what's 0 times 4? And then plus 3. You see how you get the output 3? Plug in 2 right there. 0 times 2? 0. 0 plus 3? 3. So you see, you can get a bunch of the same outputs. And it boils back down to this. If you ever plug in the same exact input and get out different outputs, that's when it's broken. So keep this in mind, guys. You don't need to state your function form equation that actually produces these outputs when you give the... All I need to know is it a machine or is it a broken machine? Is it a function or is it just a relation? You don't need to know the actual y equals 0x plus 3. But this is nice to know because that's what actually happens for these numbers. To get to the output 3, you have to use this function equation. Over here, we never stated the function, but just for funsies, how could we get from a 1 to a 3? Add 2. How do we get from a 2 to a 4? Add 2. 3 to a 5? Add 2. 8 to 10? Add 2. So what would the function form equation be? What's the actual machine that produces those outputs for the given inputs? Y equals, remember, function form is y by itself. Y equals what? X plus 2. Again, this is just extra. You don't need to know this right now. Right now, all I care about, is it a function or is it just a relation? As we saw on the second one, this is a relation because I plugged in a negative 3, got out of 15. I plugged in a negative 3 again. I'm supposed to get out of 15 again. That didn't happen. That's like having some dough, getting a donut, having some dough, getting out a tortilla. This machine's broken, right? So you call this a relation. There's some type of relationship going on, but I cannot narrow it down to y equals something x plus something, right? It just doesn't work. So we need to be able to analyze numbers like that and state whether it's a function or just a relation, but we also need to be able to analyze graphs and state whether it's a function or a relation. So when you look at a graph, you could actually look at the numbers, kind of like we were doing with the input-output tables or the XY tables. So, I mean, I could put coordinates on all these and look at the XY values, look at the input-output values. And the question is this, do I ever plug in the same input more than once? I plugged in a 3, plugged in a 2, plugged in a 1, plugged in a 0. No. So we already know it passes, right? And it is a function that works. It's a function, not a relation. So everybody label it function. Now, that's not the best way. It's not the best way to identify whether it's a function or just a relation. We have this thing that's described above right here, the vertical line test. Okay, so what is the vertical line test? You're going to take a vertical line, kind of like your pencil or something like that, and just draw that vertical line, obviously up and down. Or don't even draw it, just put your pencil. Imagine that this blue line's a pencil. And if it, as you run it from left to right, if it touches your blue line at more than 1 point, then it fails the vertical line test. And if it does only have 1 point on it, like right there, the point is right here, it only has 1 point. Right here, it only has 1 point, it's right there. Right here, it only has 1 point, that's the coordinate 2, 2. So this passes the vertical line test. That means it is a function. So using the vertical line is a lot easier. So what do you think? Does this pass the vertical line test?
No.
It only touches once, right? Never do you have one input giving you two different outputs. So this does pass the vertical line test. Imagine the blue line being your pencil and you just run your pencil across the graph. Now check this one out. Does this pass the vertical line test? Heck no. Right here it fails the vertical line test. So this one right here is not a function. What is it? It's a relation. So everybody should write down relation on this one. Okay, let's go back up. I didn't do the second one. This one passes the vertical line test, right? I mean, we could think of it numerically. I mean, you could just get a bunch of coordinates and then think about, oh, my input's -3, -1.5, 0, 3. You never plug in the same number twice and get out different answers. But it's a lot easier to just do this. Run your pencil from side to side. If it does touch at 2 places and it fails a vertical line test, which means that the machine's broken. Down here, this machine is broken. Why is it broken? And we could even be specific here. Why is it broken? Because the input 4 gives the output what? -2 and 2. So you know the machine's broken. You plug in a 4 and you get out a 2. And you also get out a -2. So it definitely fails the vertical line test. So that's a relation. So let's clarify this even further. The blue line, your pencil, it's really just telling you inputs and outputs. What input is the blue line at right there? Remember, inputs are x values. What input is the blue line at? What input, what x value is the blue line at? It's at 1, right? And what output do I get? I get the output 1 and I get the output -1. Here's the output 1, here's the output -1. So for my single input 1, I get 2 outputs. That's like saying I plugged in a 1 and I got out a 1. If I plug in a 1 again, I'm supposed to get out a 1 again, but I don't. I get out a -1. So that's how I know this machine's broken. That's a relation, no longer a function machine. You guys get it? Let's move on over here. How about this guy? Does this pass the vertical line test?
No.
Does it? Yeah. It never crosses my blue line at 2 dots, does it? So this passes. So what do we call this? Function or relation? Function. Put an F, write out function if you want, whatever you like. Let's go to this one down here. This one is the vertical line itself. It's right here at the x value of 2. If I run my blue line, blue line right through it, will it have more than 1 point touching? It has all the points touching, right? If you don't understand it, then you could just say this. Well, what are some coordinates of that red line? Say again? 2, 1. Whoops, sorry. 2, 1. 2, -1. 2, 0. 2, whatever you want, right? 2, 3. Now, what's happening with the inputs and outputs? The input 2, you plug it in, you get out a 1. You plug in 2 again, you don't get out a 1, you get out a -1. You plug in 2 again, you get out a 0. So this is definitely a messed up machine. So this is not a function, this is just a relation. Okie doke? Whoa. Function or just a relation? Relation. For that input of 0, how many outputs do I get? How many specifically? For the input 0, you get output 0, you get the output 4, and probably -4, if that's 4 and -4. So for that one input, you get 3 outputs right here, and right there. So that's definitely a messed up machine. It's not a function machine, it's a relation. Okay, let's move on. Down here, it says, determine if the graph coordinates on the class opener represent a function or a relation. Let's go to the class opener. If you do the vertical line test, will it have more than 1 point on it? No. Only 1 dot, only 1 dot, only 1 dot, only 1 dot. It'd be a different story if I had like a point E right there. Then that would fail the vertical line test because there's 2 points on it. But that's not the case. So this does pass the vertical line test, so it is a function. So right here on number 1, everybody put function. Okay, let's move on to number 2. It says, please state the range. What the heck is that? Please state the range of the class opener. What is the range? The range is the Y value. I mean, look at the diagram down here, our picture. The output is the same thing as the range, the same thing as Y values. So if they're telling you to state the range of the class opener, what's the range? It's 4, 3, -2, and 0. Again, 4, 3, -2, 0. So going back to this one, 4, 3, -2, 0. I like to put a little R right next to it. That way it's stating that's the range. Over here, the domain, we're going to say D, little colon. And what are the domain values of the class opener? Say again. 3, negative 1, 0, 4. The domain are simply your x values. Believe it or not, there's a question like this on the final. You don't even, all you got to do is know that domain are your x values, range are your y values, and you'll get it right. So back to this one, number 3. What are the domain values again, the x values? 3, negative 1, 0, 4. Thank you. Listen to this. If you have two different domain values producing the same range value, it cannot be a function. True or false? Now remember, domain are inputs. So if you have two different inputs producing the same output, could it be a function? Two different inputs producing the same output. Yeah, look, 4 gave us a 3, 2 gave us a 3. Could it be a function? Yeah, y equals 0, x plus 3. Okay? So, that is false. It can be. It can be a function. Number 5, if you plug in a 3 and you get out a 4, then you plug in a 3 again, but you get out a 2, then it's not a function, it's only a relation. True or false? That's true. That's what determines whether it's a relation or a function. You plug in a number, you get out an answer. You plug in that same number, you better get out that same answer. So we do have a homework assignment on this, but we will continue this homework assignment on another video. This video is already way too long. Here it is. Oh yeah, by the way, on the homework, it says yes, no, and why. It should say function relation instead of yes, no, and why. So you want to state whether it's a function or a relation and why. We'll pick that up on another video.